These are the examples for Geometry A, Credit 3, Lesson 5.3. Lesson 5.3, we're going to be talking about another triangle congruence theorem called side angle side, which we're going to abbreviate SAS. I'm not sure if you can see that with the glare. Let's see if we can. It's a little hard to see that, but at any rate, it's SAS represents side angle side. And so what side angle side is two sides. Let's just say we had a triangle here. It's two sides and the angle that's in between or that's formed by those two sides. So if these are the two sides, this would have to be the angle because this is the angle that is created or formed by these two sides. Or another way of thinking of it, it's the angle that's in between the two sides. All right, let's take a look at our examples first of all, for number one. And the question is what additional information would we need to prove the triangle's congruent by our new congruence theorem, side angle side? We'll write it down here. Hopefully that's a little bit more clear. All right, so in example number one, we have two pairs of sides marked congruent. We're told that AB is congruent to DE. We're also told that AC is congruent to DF. And so we have two pairs of sides marked as congruent. So what we're missing is the pair of angles. And remember, the angle has to be the angle that's in between the two sides or that's formed by the two sides. So here are the two sides in our first triangle, and they form angle A. So it would be angle A is congruent to its corresponding angle in triangle DEF. And in DEF, these two sides are marked as congruent. The angle that's in between or formed by those two sides would be angle D. So we would need to be told or be able to figure out, or at any rate, the additional piece of information is that angle A would have to be congruent to angle D in order for these triangles to be congruent by side angle side. Taking a look at an example for problem number two. So in problem number two, all we have marked is a pair of sides as congruent. And so we're still missing a pair of angles and another pair of sides. However, the question is what additional information would we need? So what's the one thing? So that seems to imply that we could reason out either a pair of angles or a pair of sides as also being congruent here. And it turns out we can. Recall from the previous lesson that when we had intersecting lines, the angles that are opposite each other are congruent. We call those vertical angles. And let's put that there as a reminder. And so here in our diagram, we have these angles here are created by these intersecting lines, and the angles that are opposite each other are vertical angles, so they would be congruent. Now, so that gives us a pair of angles. So now we're missing a pair of sides. And so let's take a look in our top triangle here. Here's our angle. We have this side marked, but this side is not. So it would have to be side BC would have to be congruent to its corresponding side in this triangle. So once again, we look at this angle here. This side is already marked. This side is not marked. So BC would have to be congruent to this side here, EC. And so that's the additional information that we would need in order to say that these triangles are congruent by side angle side. All right, so now let's take a look at examples for problems 3 and 4. And again, pause, rewind the video as needed in order to get a better understanding of what's going on in each of these problems. So our example for number 3, we've got this figure here, a parallelogram, but it's divided into two separate triangles. We're going to call this ABCD. And we're also told that these two angles here, we're marking those as congruent. So all we have here in this one is, in this problem, is a pair of angles marked as congruent. So once again, we're going to have to reason out something else, either about one pair of sides or the other. We only need one pair of angles. We already have that. So it's got our remaining information involves sides. So it turns out that these two triangles share a side, BD. BD is part of the top triangle, if you will, or the triangle on the left. And then BD is also part of triangle BCD, the other triangle here below. And so when a side is congruent to itself, we could say that BD is congruent to BD, which seems kind of obvious, doesn't it? I mean, something's going to be congruent to itself, but we do actually give a name to that, and we call that the reflexive property. When something is equal to itself, even though that's pretty obvious, we still have to state it and give a justification for it. So BD is congruent to itself, so we do have a pair of sides. Even though it doesn't look like it's a pair of sides, it is a pair of sides because remember, BD is part of both triangles, and so BD is congruent to itself. So that's not our final answer. So our final answer is, what additional information do we need to state that the triangles are congruent? Well, we still are lacking a pair of sides. So in our top triangle, here's our angle that's marked, and here are the two sides that form that angle. We already have BD, so we're missing the top side here, AB. So AB would have to be congruent to its corresponding side in the other triangle. And I'm actually going to erase this. We don't want to confuse that as being the answer. So down in our the lower triangle, the triangle on the bottom part of our figure here, here is our angle that's marked as congruent with the other angle. And here are the two sides that form that angle. This side is already marked, so it would be this side down here, which would be side DC. So AB would have to be congruent to DC in order for these triangles to be congruent according to the side angle side congruence theorem. All right, looking at an example for our last problem, example for number 4, we have another figure similar to number 2. So let's go ahead and draw that. It's just kind of tilted on its side, but still the same idea. I'm going to label this A, B, C, D, E. And we're going to be told that these sides are congruent, and that is it. That's all we're given. All right, so in this one, number 4, we have a pair of sides marked as congruent. And you might recall from the example for problem number 2 that intersecting lines form form angles, and the angles that are opposite each other, vertical angles, are congruent. So here's our intersecting lines. The angles opposite each other are congruent. So we know that. And so what we're missing now is a pair of sides. And so as we've seen a few times, and I think maybe even try pausing the video for a second to hear to see if you can figure it out. And hopefully you did that. And so let's take a look here. So in the top or the triangle to the left, here's our angle. Here are the two sides that form it. This one is marked. So we're missing side BE. So BE, we'll go ahead and mark that. And that would have to be congruent to its corresponding side in this triangle. Here's our angle. Here are the two sides that form that angle. This one is marked. So the side that's not marked is down here, which would be ED or BE. Well, it's named in the same order, out to in, so DE. And so we would need to know that BE is congruent to DE in order to state that these triangles are congruent by side, angle, side. All right, that's it for the examples for lesson 5.3. Again, as we've said earlier, pause, rewind the video as needed, and I'm sure you'll do great with the work. Good luck with the work, and we'll see you in the next video. Take care and God bless.